let's move on and talk about utility functions, which is let's move from these preference assumptions to what we really need to do is mathematically represent those preferences. And then we're going to mathematically represent those preferences come from something. Okay, I just heuristically described this grad student, but what was the underlying mathematical function that generated his indifference between Princeton and Santa Cruz? Okay, well, that was his utility function. That was the underlying measure of his well-being that generated those indifference curves. And we'll talk now about how that works. Okay? So to make life easy, let's go back to our example of pizza and movies. And imagine my utility function is of the form, my utility is equal to the square root of the number of pizza times the number of movies. Forget where this came from for the moment. Just say this is my preference, this is my representation of my preferences, representation of my underlying utility. Okay? So what this means is what this mathematical function generates is a number of results. So for example, what this says is I am indifferent between 1 pizza and 4 movies or 2 pizzas and 2 movies, right? Because both generate square root of 4 utility. Likewise, I prefer 2 pizzas and 2 movies to 1 pizza and 2 movies, because square root of 2 is greater than square root of 4 is greater than square root of 2, etc. So we could see how utility function generates the kind of preferences we just talked about. Now, when you see this, the first question you ask is, well, what is U? What are utils? And the answer is they are nothing. The answer is this is not a cardinal concept. This is an ordinal concept. What I mean by that is the number that is utility is meaningless. All utility functions do is allow us to relatively rank different choices. They don't allow us to say, I am made X much more happy by 2 pizzas and 2 movies than 1 pizza and 2 movies. That's a meaningless concept. They just let us rank which makes me happier and among which I'm happier and among which I'm indifferent. Okay? That's what utility does. Okay? So you cannot say a utility of 4 is twice as good as utility of 2. You can say utility of 4 is better than utility of 2. Okay? It's an ordinal concept, not a cardinal concept. As a result, this allows us, for example, to say that any normal transformation of utility function gives the same answer. So if I take if I take utility function and I square the whole thing or take it over 2 or something like that, I'll always get the same answers. The U's will differ, but the rankings of choices never will. Okay? So basically, that's what utility functions do. So this is really kind of abstract that we've just written down this mathematical function. But with this simple assumption, and these three, with this representation, these 3 assumptions, we will be able to describe consumer choice in a wide variety of contexts pretty powerfully. Okay? So let's get there. Let's now take this first step. Obviously, we can't finish it up till we impose budget constraints. We can't tell you why you choose what you should do in budget constraints. What I wanted today is help you understand how the features of these utility functions lead us towards the choices we make. And the first thing we're going to talk about is we're going to talk about the concept of marginal utility. Marginal utility is simply the derivative of the utility function with respect to the quantity of the good. So the marginal utility of pizza is the derivative of this utility function with respect to pizza. The marginal utility of movies is the derivative of this utility function with respect to movies. And the key thing that we learn, the key feature of the kind of utility functions we'll use in this course, by and large, is they will feature diminishing marginal utility. Diminishing marginal utility will be a key feature of the kind of utility functions we'll almost always use in this course. Okay? So we can see this in figure 4.4. Figure 4.4 actually literally graphs, even though utils don't mean anything, we're graphing the utils. Excuse me. We're graphing the utils from different quantities of movies holding the number of pizzas constant. So let's say you have 2 pizzas. That's never changing. But you have a choice of how many movies you're going to see, 1, 2, 3, or 4. Well, if you see one movie, okay, so in parentheses, the numbers here, the first number is the number of movies you see. The second number is the utility it delivers, the utils it delivers. So you see one movie, your utility is square root of 2, which is 1.4. 2 movies, your utility is 2, which is square root of 4, etc. So with each movie you see utility goes up. It has to go up because more is better. Doesn't matter what the movie is. More is better. Okay? But it goes up in a diminishing way. It goes up by less and less, as we can see mathematically in the next panel, figure 4.5. Okay? Flip the page. This is just, I just graphed the delta in utility. Okay? As the number of movies increases, you see the first movie, going from no movies to 1 movie, raised utility by 1.4. Going from 1 movie to 2 movie raised it by 0.59. Going from 2 movies to 3 movies raised it by 0.45, and 3 movies to 4 movies raised it by 0.38. Okay? This is diminishing margin utility. Okay? Why does this make sense? Okay? Well, think about movies for a second. You've got your 2 pizzas. You're nice and full. Now it's time to, you gotta, the semester's over, you're vegging out, you got plenty of free time, and your friends say, let's see some movies. And you have to ask yourself, well, look, I definitely want to see Black Mass. Definitely want to see that. Very excited to see that. I'm pretty excited to see Everest. That'd be pretty cool. Looks like cool special effects and crap. Okay? After that, I guess I'm kind of excited to see whatever the hell else is out. I don't know. I've used up my knowledge of current movies. Okay, whatever shows my preferences. Whatever else is out. And then by the time I get to the 4th movie, like, I'm just not that interested in seeing movies anymore. I mean, I'll see it because, more is better. But, it's not going to make me that much happier. Or likewise, let's flip it around. Imagine you're seeing 2 movies, and your friends say how much pizza you want. Well, the first pizza is like, yeah, I want pizza. I'm hungry. That gives me a big margin utility. Second pizza is like, yeah, I still want pizza. Okay, I'm still pretty hungry. I'm kind of full, but, another pizza wouldn't hurt. Third pizza, you're like, oh, I'm getting kind of full, but more is better, so I guess I'll have some more. By the 4th pizza, you're like, oh, geez, I know more is better, but this is getting ridiculous. Okay? So basically, diminishing margin utility, each pizza, you want each pizza or each movie is worth less and less and less. And if you understand this concept, you will be able to do everything you need to in consumer theory. This is the key concept. Okay? Because this concept generates the key negative correlation that we'll talk about between quantity and incremental happiness. The more of something you get, the less incrementally happy it makes you. Okay? And that's going to drive most of what we'll do in this section. Okay? So diminishing margin utility is the key feature here. Questions about that?